Okay, welcome IB Chemistry students. Today we're going to talk about stoichiometry. It's our first video, and for this chapter, and what I've done is I've combined 3 chapters into one, chapters 3, 4, and chapter 10 in the AP Chemistry textbook, because this is going to help you prepare really for the AP Chemistry exam. The IB exam does some of this stuff, especially chapter 3 is what it focuses on. It does a little bit of gas laws, and it does a little bit of solution stoichiometry, but the AP exam really does a lot more. So these are your goals for chapter 3 from the AP Chemistry textbook, which you don't have. You're welcome to come and pick one up. This corresponds to the first chapter in your textbook, which is the stoichiometry chapter. So when we define stoichiometry, what we're really looking at measuring quantities in a chemical reaction. And we want to compare them. So we're going to compare different units. And you've done this before. If you remember back from honors chemistry, we did a lot of stoichiometry. It was probably one of our most difficult units. It was a unit where you had to really know how to do the conversions between the different quantities that you were given. So all stoichiometry is based on the idea of the law of conservation of matter, or mass. And so when we do stoichiometry problems, the first thing that we need to do is to balance an equation. So if I give you an equation like nitrogen plus hydrogen yields ammonia, I need to balance this equation. And so to do this, we're going to talk more in detail about how to balance equations. But to do this, I would put a 2 in front of the nitrogen and a 3 in front of the hydrogen. If I count up all the atoms on each side, I'll have 6 hydrogens, I'll have 2 nitrogens, I'll have a balanced equation. Central to any stoichiometry type of question is the mole. So what is a mole really equal to? Well, a mole is equal to a certain number of atoms, molecules, units of a substance. And the reason why I put all of these disclaimers in is because it depends on what type of substance you have. You know, so for example, if I were to have 6.022 times 10 to the 23rd, that could be equal to 1 mole of, sodium. Or it could be equal to 1 mole of calcium. So if you have 1 mole of calcium, you have this many atoms of it. But then I could have a substance like an ionic substance, like calcium chloride. And so for calcium chloride, if I have 1 mole of calcium chloride, then I'm going to have 6.022 times 10 to the 23rd units of that, or particles of that. And why do I use this term particles or units? Well, when I look at this, I know what calcium chloride is made up of. It's made up of a calcium ion, and it's made up of 2 chloride ions. And so what's important about this is that if I have 1 mole of calcium chloride, well then I have really 1 mole of calcium, and I also have 1 mole, oh sorry, no I don't, I have 2 moles of chloride ions. What does that mean in terms of particles? Well, that means that if I have 6.02 times 10 to the 23rd of this, then I'm going to have 6.02 times 10 to the 23rd of the calcium. But for the chloride, I'm going to have 12.04 times 10 to the 23rd chloride. I have double. And this is a little nuance that you have to understand. The difference between the language that they're going to use with you. So here's an example with 1 mole of calcium hydroxide. So let's say if I were to ask you, well, how many CaOH2 particles are there? What if I were to ask you how many ions are there? What if I were to even ask you how many atoms there are? Let's see if you can go through and figure those out. Tomorrow we'll talk about that particular problem. We'll see what you come up with. But here, and as you can see, like, you have to be really careful about the language, because depending on the language that they ask you will depend on what they really want you to know. So, what is a mole equal to? Well, we already came up with the idea of a mole being equal to a certain number of particles. You should know the name of that number, that Avogadro's number, and I can write that here. Avogadro's number. But, in the lab, we're rarely dealing with particles. So I'm going to stop right here because I realize that it is commons and I have to go to my commons class, but I will come back.